Hello viewers, this is Ronald taking you through today's tutorial for A-level Math Paper 2, and this tutorial we are going to talk about questions on equilibrium of a particle. Now this topic is still under mechanics and it's beneficial to students in both senior 5 and senior 6. Now these are the very questions I left in the previous video, and I believe by now you have already tried them out and ready to mark yourself and check your progress. So we shall start with question 1. Question 1 says, a particle of mass 2 kilograms rests in equilibrium on a rough plane inclined at 30 degrees to the horizontal. Know that word, 30 degrees to the horizontal. Find the value of the coefficient of friction, and they give it 5 marks. So such questions are easily done by first making a sketch of the force diagram. So we shall make a sketch of the force diagram. So this is what it was given. We are told that a particle of mass 2 kilograms rests in equilibrium on a rough inclined plane at 30 which is inclined at 30 degrees. So this is the particle of mass 2 kilograms, and this is the plane which is inclined at 30 degrees to the horizontal. So next is now to put the forces. We shall begin with the weight of the particle. Remember, weight acts vertically downwards, it will be 2g newtons. But in this case we have to resolve into two components, one which is parallel to the plane and it will be 2g sine 30, another component which is perpendicular to the plane and it is 2g cos 30. So the reason why these resolved components are dotted, it is because it is not a force on its own, it is just a resolved part of the weight of the particle. So always remember to make these resolved components with dotted lines. So next is to show the normal reaction, which is capital R, and the friction, which is small f, in that direction. So now that you have made a sketch, next is to answer the question that followed. They told us that the particle rests in equilibrium and they want you to find the value of the coefficient of friction, which is small f. So we shall come and say, resolving perpendicular to the plane, so this is the perpendicular to the plane, we shall have R being equal to 2g sine 30. This will be equal to that. Then next we shall also resolve parallel to the plane, and parallel to the plane we shall have this f being equal to 2g sine 30, which is that. So but we know that friction is equal to mu r, where mu is the coefficient of friction and this r is the normal reaction. So what we shall do, we shall come and substitute. We know r, we know f, so come and substitute for r and f, so that we remain with one unknown, which is mu. And when I simplify and make mu the subject, I'll come up with mu being equal to 0.5774. So basically that's what they wanted, because they wanted the value of the coefficient of friction, and that is mu. So next is to see how marks can be awarded. So in this case, B1 is for the correct force diagram, and remember this force diagram is drawn using a ruler. Then B1 is for resolving perpendicular to the plane, then this B1 is for resolving parallel to the plane, and this M1 is for substituting F and R into this formula. Then this A1 is for simplifying to get the coefficient of friction, which is required. So basically that's how the 5 marks could come about. So now shall go to question 2, and question 2 says, question 2 came from UNEB 2012 paper 2 question 6, and it says, a light inextensible string passes over a smooth pulley fixed at the top of a smooth plane note this word, smooth plane inclined at 30 degrees to the horizontal. A mass of 4 kilograms, or this mass 4 kilograms, is attached to one end of the string and hangs freely. Note that word, hangs freely. A mass m is attached to the other end of the string and rests on the inclined plane. So this mass m rests on the inclined plane. You should also know that. So they ask that if the system is in equilibrium, find m, and they give it 5 marks. So like I said, such questions are easily done by first drawing a force diagram. So we are going to first draw a force diagram to show the given information. So we are told that the inclined plane, the plane is inclined at 30 degrees, which is that, and there is a fixed pulley at the top of that incline. Now there are two masses. One is resting on the inclined plane, another one is hanging freely, and they are connected by a string, which is this. So basically that's what is given, and we are told that this m is the one which is resting on the inclined plane, and this 4 kilograms is the one which is hanging freely. So we shall use that to show the forces that are on this diagram, on the particles. So we shall start with the force with the weight of the m kilogram mass. Remember, weight acts vertically downwards, but since it is on an inclined plane, we shall resolve the weight into two components, one which is parallel to the plane, another one which is perpendicular to the plane. The one parallel to the plane is mg sin 30, the one perpendicular to the plane is mg cos 30, and remember, these resolved components must be represented by dotted lines. So after showing the weight, we shall now show the normal reaction, which is R. Then next we shall show the tensions in the string for this part, which is T, and then and should also note the direction of these tensions. Now that we have done with this m kilogram mass, now we shall go to the 4 kilogram mass and show the forces acting on it. So first we shall begin with the weight of that 4 kilogram mass, which is 4g newtons, and after that we shall show the tensions in this string, which is also T. Now we should note that the tension is the same throughout the string because the string is still the same. It is continuous. So when the string is continuous, the tension will also be the same. So basically that's what was given in the question, and remember they told us that it's in equilibrium. So we shall begin with the 4 kilogram mass and shall say for the 4 kilogram mass, T is equal to 4g. When I resolve vertically, T will be equal to 4g, but I know that g is equal to 9.8, so when I substitute I'll come up with T being equal to 39.2 newtons. So now that I've got T, I can come and resolve for this m kilogram mass. So for the m kilogram mass, when I resolve parallel to the plane, I'll come up with T being equal to mg sine 30, which is that. So I know T and I know g, so I'll come and substitute for T and g, so that I remain with only m as the unknown, and when I make m the subject, I'll come up with m being equal to 8 kilograms. So basically that's what they wanted in this question, and now let's see how mass can be awarded. So the first mark is for the correct force diagram, and remember these force diagrams are drawn using a ruler. Now M1 is for resolving the 4 kilogram mass, then A1 is for the output, which is the tension in the string. Then this M1 is for resolving for the m kilogram mass, and A1 is the output, which is the mass. So this is supposed to be mass, not tension. So basically that's how the 5 marks could come about in this question. Now we shall go to question 3, and question 3 came from UNEB 2010 paper 2 question 5, and it says a carton of mass 3 kilograms rests on a rough plane inclined at an angle of 30 degrees to the horizontal. The coefficient of friction between the carton and the plane is 1/3. Find a horizontal force that should be applied to make the carton just about to move up the plane. Note that the word just about to move up the plane. Like I said, such questions are easily done by first making a sketch. So what we are going to do, we are going to make a sketch of the information given. First, we shall say that let F be the required horizontal force. And now that we shall now make a sketch. So this is the inclined plane, inclined at 30 degrees to the horizontal, and this is the particle. Now that we have made that, we shall now show the forces acting on this particle. We shall begin with its own weight. The weight acts vertically downwards and it will be 3g newtons, and this weight will be resolved into two components: the horizontal the component part of the plane and the component perpendicular to the plane. So the one part of the plane will be 3g sine 30 degrees, and the one perpendicular to the plane will be 3g cos 30 degrees. So next is to show this horizontal force, which is keeping it in equilibrium and so that it's just about to move up the plane. So this horizontal force is capital F, which is this, and it will also be resolved into two components: one which is part of the plane and it will be F cos 30 degrees, and the one which is perpendicular to the plane, which is F sine 30 degrees. Now next is to show the normal reaction, which is capital R, and the friction, which is small f. Friction is acting downwards because this force is makes the particle to be just about to move up the plane, and remember, friction opposes motion. So now that you have made a sketch, you shall now come and resolve. So resolving perpendicular to the plane will give R being equal to F sine 30 degrees plus 3g cos 30 degrees equal to 0.5 F plus 1.5g root 3. So I think I realize that sine 30 is equal to 0.5. That's why you see here 0.5. Then you also realize that cos 30 is equal to root 3 over 2. Now root 3 over 2 times 3 will give you, a half times 3 will give you 1.5, and the multiply by root 3 to give you 1.5 g root 3. So this was a simplification of this. Therefore R is equal to 0.5 F plus 1.5 g root 3. Now that we know R and we know the coefficient of friction, we can come and get the friction, which will be equal to mu R. Now mu is 1/3, so 1/3 times 0.5 F plus 1.5 g root 3 will give us 1/6 over in brackets F plus 3g root 3. So now that we know the friction, we can go ahead and resolve parallel to the plane. So when I resolve parallel to the plane, I will come and get F cos 30 degrees being equal to F plus 3g sine 30 degrees. So this F cos 30 degrees will be equal to small f, which is the friction, plus 3g sine 30 degrees. But I know my f, small f is given by this, so I'll come and substitute. So cos 30 is equal to root 3 over 2, which is equal to this 0.5 root 3 times f, which is that. Then small f is equal to this, which is here. Now sine 30 is a half. Now half times 3 will give you 1.5, which is that. Now I think you realize that we have only one unknown, which is capital F, because g is a constant. So what you are going to do, you are going to look for ways of making capital F the subjects, and when I make up capital F the subject, I'll come up with capital F being equal to 33.1547 newtons, and basically that was the horizontal force that was required. Now let's see how much can be awarded. So B1 will be for the correct force diagram, and remember, force diagrams are drawn using a ruler. Now this M1 is for resolving perpendicular to the plane, which is that. Then this m1 is for resolving parallel to the plane to come up with this, and this m1 is for substituting for f into this resolved components and simplifying. Then a1 is for the final answer, which is 33.1547 newtons. So basically that's how the 5 marks could come about in this question. So now we shall go to question 4, and question 4 came from UNEB 2009 paper 2 question 5, and says a body of mass 8 kilograms rests on a rough plane inclined at theta to the horizontal. If the coefficient of friction is mu, find the least horizontal force. Note that word, least horizontal force, in terms of mu, theta and g, which would hold the body in equilibrium. So first thing to do is to make a sketch of the given information. So just come and say that let F be the required horizontal force, which is the least horizontal force. And now that we know that, we shall come and make our sketch in that way. So this will be the particle, and this is the plane which is inclined at an angle theta to the horizontal. Now next is to show the forces acting on that particle. We shall begin with its weight. So weight will be equal to 8g newtons, and we shall also resolve it into two components, one which is part of the plane and it is 8g sine theta, and the other which is perpendicular to the plane, which is 8g cos theta. Remember, these resolved components must be dotted. So now that we have shown the weight, we shall now come and show the horizontal force which is required by capital F, which is that, and we shall also resolve it into two components, one which is part of the plane, it will be F cos theta, another which is perpendicular to the plane, and it will be F sine theta. So the next is to show the normal reaction and the friction. So this is the normal reaction R, and this is the friction small f. Now this friction is acting upwards because they told us that this F is the least horizontal force. Being the least horizontal force, it means that the particle is just about to slide downwards. Therefore the force friction will oppose motion by acting in that direction. So now that you have sketched put the given information in the first diagram, we shall now go ahead to resolve. We shall begin by resolving perpendicular to the plane, and when I resolve perpendicular to the plane, I'll come up with R being equal to F sine theta plus 8g cos theta. So this R is equal to F sine theta plus 8g cos theta. But I know that F is equal to mu R, therefore my small f will be equal to mu in brackets F sine theta plus 8g cos theta. Now that I know friction, I'll go ahead to resolve parallel to the plane, and when I resolve parallel to the plane, I'll come up with F cos theta plus small f being equal to 8g sine theta. And when I substitute, I'll come up with that expression. I think realize that in this case we can now get our horizontal force in terms of mu, theta and g. So after substituting, I'll come and simplify. So when I open brackets, I'll come up with that, and when I simplify, I'll have to divide throughout by cos theta. So when I divide this by cos theta, this cos will cancel to remain with only f. When I divide this by cos theta, I'll come up with tan theta, which is that. When I divide this by cos theta, I'll come up with 1, which is, that's why here there's no cos. When I divide this by cos theta, I'll come up with tan theta, which is that. So in that case, I'll come and make, now my aim is to make capital F the subject, and then when I make capital F the subject, I'll come up with capital F being equal to 8g in brackets tan theta minus mu, everything divided by open brackets 1 plus mu tan theta. So basically that's what they wanted in this question, and now let's see how marks can be awarded. So the first mark is for the correct first diagram, and remember, a first diagram is drawn using a ruler. Now M1 is for resolving perpendicular to the plane, and this M1 is for resolving parallel to the plane and substituting for small f. Then this M1 is for simplifying by dividing throughout by cos theta, and this A1 is for the output, which is expressed in the simplest form possible. So basically that's how the 5 marks could come about. So I believe you have marked yourself and checked your progress. So now what I'm going to do, I'm going to leave you with a set of questions on Newton's laws of motion, and this topic is still under mechanics, and it is beneficial to both senior 5 and senior 6 students. So that brings us to the end of this video. Thank you for watching, and be reminded that the solutions to the assignment left will be available in the next video. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video of the solutions has been uploaded. Otherwise, thank you for watching, and if you know any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.